My name is Masato Sekine from Joshibu University of Art and Design, Japan. Today we'd like to propose shell-shaped smart clothes for non-verbal communication. Here is a table of today's contents. In the beginning, we'd like to introduce the background of our research. Recently, the smart clothes equipped with a range of sensors and actuators has increased. These are mainly for monitoring or logging physical information of the wearers themselves, for sensing surrounding environmental information, and for keeping the body warm and cool. However, there are only few examples focusing on the function of nonverbal communication media, which is one of the important work of clothes. In Japan, nonverbal communication is very important, and there is a communication habit called reading the air, in other words, picking up on subtext. This includes reading the facial expression or behavior of other people to tell whether they are in the mood to talk. However, Japanese people tend not to express their emotion very clearly. Therefore, picking up on subjects requires higher observation powers and higher awareness of others. On this background, our aim is developing smart clothes that support other people to judge whether wearer is in the mood to talk. Next, we'd like to talk about development. Our aim is developing smart clothes that support other people to judge whether wearer is in the mood to talk. As a concrete method, we came up with smart clothes that gradually change the appearance of clothes according to the stress level of the wearer. The higher the stress level of the wearer, the more it becomes a shape that rejects external influence. And the lower the level, the more open and natural appearance. We first sketched a proposal for a shape that will resist outside interference. One is a spike-like shape, and the another is shell-like shape. Of these, we decided to adopt the shell shape. The reason is that the spike-like shape not only rejects interference paths, but also implies the attack, while shell shape can purely express the implication of shutting out interference. We designed clothes in which shell appears and disappears according to the stress level of the wearer. One way to realize such clothes is to physically change the shape with actuator, for example, using biometal. However, since the purpose is to change the impression, it is possible to change the appearance by changing the color or optical operation. Therefore, as a textile, we choose a functional liquid film, functional liquid crystal film, which turn transmissive when a voltage is applied. This is the liquid crystal film. It is usually opaque, but it instantly becomes transparent when a voltage is applied. Using this film as a textile, we created this pattern to construct the shell structure. It consists 5 parts. Each part can be controlled separately and 2 auxiliary parts made with ordinary plastic film. By making this a layered structure, the wearer's stress level can be expressed in stages. Here is the assembled image. A wearer can choose and wear their own innerwear. The innerwear is, so to speak, equivalent to the original appearance of the wearer, with the shell removed. Next, I will explain the stress level rating system. The, the simplest way to indicate if the wearer does not want to be talked to is to set the level by themselves. However, this method is labor intensive, as wearer must always be aware of the level setting. Therefore, we decided to adopt a system which automatically rates the stress level with sensors. The system measures the skin conductance and heartbeat, which are often used as biometric information indicating the degree of tension. Here is the algorithm of stress level rating. At the first step, it needs setting maximum and minimum value of use range of sensor signal. Because the signal range will vary depending on the physical characteristics of the wearer and the situation. In the rating process, when the signal value exceeds the range, it will be clumped at maximum and minimum values. And normalize the values and calculate stress level with a simple linear combination. Next, I'll show the prototype demo. Conclusion. We developed shell-shaped smart goals in order to support other people to judge whether wearer is in the mood to talk. It is the first prototype, and the stress level rating algorithm is a simple linear model and may lack accuracy. In addition, for the mobility, the prototype power source can only be supplied by wired at present, and we'd like to be able to supply it by battery. Our specialty is media art and fashion design, but in the future, we'd like to update to a more sophisticated system by collaborating with experts in the field of informatics and engineering. Thank you for listening. And do you have any question? Today, I have an English-friendly colleague as a translator, just in case.
Thank you, Masatos, again for your nice presentation. And yeah, audience, if you have any questions, please kindly send them. Yeah, Masato, you have some questions. Can you give me an idea of the cost of the liquid crystal film?
Sorry, what do you say?
Can you give an idea of the cost of the liquid crystal film?
このクリスタルフィルムの、このフィルムの価格、コストはどれくらいですか？
コストは、
cost。
これは提供してもらってるんですよ。
実際そう市場での価格
です聞いてないんです。これだから研究用に提供してもらってるので市場価格は聞いてない。
なるほど。So actually, this film is just given from the company for just this research project. So actually, it's not in the market yet, and actually, we have no idea about the concrete price in the market.
Yeah.
This film.
Yeah, I understand, and thank you for your answer. And the next question is that. Yes, I mean.
Can I get a question?
Yeah.
Just quickly. Yeah. Thanks so much, Sekine. This is really interesting presentation. I'm just curious about your opinion about using such technology with kids who have burns. Kids who have burns go to hospitals and cannot explain to doctors and to family how they feel pain. So can we use such technology to change color depending on how he feels pain? Just your opinion. No, it's futuristic, but just your opinion. I'm about that. Thank you.
Thank you.
病院で子どもたちの中でやけどを負った子どもたちがなんていうかこの痛みをですね表現するのに使えそうなテクノロジーですね。その点に関してどのような考えをお持ちですか？
なるほど。
もし何かアイディアがあれば。
確かに、ストレスレベルなので、ストレスを感じていれば服の方に影響出てくるので、そういうことにも使えると思います。
So this is a very good point. Your question is a really good point. Actually, this system is capturing the human stress. So if the children has a big stress depending on this burn or pains, so this cloth can express how children has a stress level, how it's big or less. So it could be used for in that field as well, and not only for burned children or many injury or illness which has a pain.
Yeah, thank you.
There's a nice venue for research. Thanks so much, Masato.
Thank you.
Yeah, Masato, you have one more questions from Haran. He asked that question is that could the system can be used outside, and how about the body movement?
これ外で使うことはできますか？それからこの動きはどれくらい可能ですか？
今は本当にプロトタイプなので、動きっていうのは結構限られちゃうんですけど、バッテリーで、動くようになって、あと構造とかも、変えられるので薄いですし、結構自由に動けるように作ることはできます。
Now, actually, we have a very prototype here, so it needs a line for giving a voltage. But in the future, we are considering to make it is only battery, so it could be more easy mobile, and also the movement. Actually, this film is quite thin, so it's very flexible material. So. So just changing and developing the design, it could be more flexible, more free move.
Yeah, thank you for your answer, and really it's a nice presentation.